Okay, guys, open your books and come on page 52, please.
Workbook.
No, your course book, science book. Okay, today my topic of discussion is magnetic induction. And at the end of this lesson, you students should be able to understand how magnetisms can be induced in a piece of iron or steel and to distinguish between magnetic and non-magnetic materials. Before starting our today's lecture, let's preview your previous lecture. Previously, we were talking about the magnetic field. What is the magnetic field? The space or region around a magnet where its force of attraction or repulsion experienced there called magnetic field. And then we were talking about when the magnet is broken, then all of its pieces are becomes complete magnets. None of the pieces should be separated in north and south pieces, but combinedly, each and every particle of the broken magnet becomes a bar magnet. The N pole of the magnet attracts the S poles of the magnet as it moves across the iron. If you move across the iron, then the particles of the N pole of the magnet attracts the S pole of the magnet. And at the end, we were talking about that energy from heating causes molecule to move faster. Because from heating, the molecules gains energy, and as a result, what happens that it will move in a faster rate. So this is all about your previous lecture. Now today, let me start from electromagnetic induction. Dear students, you can see in this figure that there are three things. This is a coil, a bar magnet, and an ammeter. If you bring this bar magnet close to this coil, what will happen? This coil will comes in the magnetic field of this bar magnet. And as a result of that magnetic field, the current will be generated in this coil. And because of that current, the needle of the ammeter will be deflected in either side. So electromagnetic induction, after that, we can explain the electromagnetic induction that a changing magnetic field around a coil of wire induces an electric field. What does it mean? That if you change the magnetic field around any of the metallic coil, what will happen? The free electrons there in the coil will be aligned in a specific direction, and that will cause a current that will be generated there in that coil, and that is so called induction. Electromagnetic induction means that because of the magnetic field, if a current is generated there, then we can say that phenomena are electromagnetic induction. Come towards your book. In your book, magnetic induction is when a piece of iron or steel is placed near a magnet, the magnetic domains lines up and it becomes magnetized. Earlier, I explained what are magnetic domains. Basically, magnetic domains are the atoms or molecules inside a magnetic material. Usually, those magnetic domains were unaligned or they will be aligned randomly. It means that in each and every molecule or atom are in random direction, and if you apply a magnetic field upon those magnetic domains, what will happen? They will become magnetized. It means that they will be in the same line of action or they will be aligned. This is so-called induced magnetism. This phenomena is called the induction. The diagram on the next page shows the induced pole closest to the magnetic. S pole is a N pole is a S pole. This explains why magnets attracts iron and steel. This is the phenomena how the magnet attracts steel or iron. Now you can see here in this figure, from this figure, things will be quite clear to you all that how a temporary magnet and how a permanent magnet forms. Now come towards the temporary magnet first. From in a temporary magnet, what will happen that when the iron is pulled away from a magnet, it loses its induced magnetism. You can see here from this figure, this is so-called a bar magnet. This is so-called a bar magnet, and this is an iron piece. This is an iron piece. If you come close that magnet to the iron piece, what will happen? Because of the magnetic field, this iron piece will become magnetized. And if you remove that magnet from the iron piece, the iron piece loses its magnetism and it will become an iron piece again. So this is what's so called the temporary magnet. When an external magnetic field is applied on a material or a metal, and because of the external magnetic field, that metal induces or that metal induced, and after removing the external magnetic field, that material loses its magnetism. We can say a temporary magnet. I think this thing will be quite clear to you all. Now come towards the right hand side of this figure. You can see here, this is a bar magnet. It is quite clear for you all. This is a piece of steel. If you bring closer this bar magnet to this piece of steel, what will happen? A magnetic field, it will this steel piece will comes in the field magnetic field of that magnet, and as a result, the steel piece will be magnetized there. And if you remove the external magnetic field, what will happen? You can see here that this steel stays magnetized. Okay, this steel retains the magnetic properties or magnetic character that will gain from the magnet. They retain that magnetic character, and as a result, this steel becomes a permanent magnet. So those materials which loses its magnetic character after the removal of the external magnetic field, we can say them temporary magnets, and those materials which retain its magnetic character after removing the external magnetic field, we can say them a permanent magnets. From this figure, things will be quite clear to you all that how the current is generated in the pulses. You can see here, this is what's so called the cross-section of a magnetic material. And these are the particles or atoms and molecules present in this material. If you apply the external magnetic field, if you bring closer the positive terminal of the battery to the magnetic material, you can see here that all the atoms are aligned. Okay? All the atoms are aligned in this case, and it will generate the current. But in the same cycle, if the negative pole is comes and they will be disappear or they will be unaligned, and after completing the cycle, the next cycle will start, and the positive terminal comes again, all the atoms or molecules of the material align again, and that will cause the current. So the current will be produced in pulses. That is, the current should be produced that will be on and off character there. So this is all about how currents generates. Now come towards the hard and soft magnetic materials. Iron is a soft magnetic material. As I explained earlier to you, that iron is a soft magnetic material. Why it is a soft magnetic material? Because after removing the external magnetic field, it loses its magnetic character. So it is easy to magnetize, but it loses its magnetism easily. This makes it useful where a temporary magnet is needed. So we will use that soft magnetic material like iron in those places where we needed the magnetism or the magnetic characteristic for a very short time. Okay, and where the direction of the magnetism has to be changed quickly. or if we change the direction of the magnetism, uh, impulses are in quick time. So we should use soft iron or soft magnetic material there. Steel, on the other hand, is a hard magnetic material, as I already mentioned you, that steel is a material in which it retains its magnetic characteristics. So we can say that it is a hard magnetic material. It is more difficult to magnetize than iron, but does not loses its magnetism easily. Once steel is magnetized, it is quite hard as compared to the iron that steel is magnetized. But once steel is magnetized there, what will happen there? It will retain its magnetic characteristic, but it doesn't lose its magnetism easily. So steel makes good permanent magnet. If you want to make a good permanent magnet, so you should use a steel. Okay, it means that once a steel will become a magnet, it is quite hard that it will be demagnetized because it retains its magnetic characteristic for a very long time. These are the magnetically soft materials, okay? Iron, cast iron, carbon steel, manganese, and nickel steel, etc. All these are the examples of magnetically soft materials. This is a very good example for you how to make a permanent magnet inside your house, okay? So you should use a magnet, you should make a magnet like in this way. We all know that steel is a hard magnetic material. Okay, you can see here there are two things. One is so-called this paper clip. This is a paper clip, and this is a bar magnet. Okay, both. If you have both these things, then you should make a permanent magnet in your home. It is quite harder to magnetize, but keep its magnetism. It is used to make permanent magnets. What should you do there? That if you bring this paper clip close to the bar magnet, and what will happen because of the magnetic field of this bar magnet, this paper clip will become magnetized. You can put them together for some time, and if you take this paper clip, then what will happen? It will become a magnet. Okay, it will become a magnet there. So this is the way how you should make a magnet inside your house. So usually this paper clip were made from steel. Okay, usually that paper clip were made from steel, so it will be easily magnetized. And once it magnetized, it will retain its magnetic characteristic, and then you should use it like a magnet. Here is properties of magnetic material for you. Hard magnetic material. Its examples are cobalt and nickel. Okay, and they were more difficult to magnetize. Hard magnets are those that were more difficult to magnetize. And once if they are magnetized, don't loses their magnetism easily. On the other hand, soft magnets are iron is a simple or in a nail, and they were easily to magnetize, and they can be easily demagnetized by physical shock or heating. If you strike them or if you hit them, then what will happen? It will lose its magnetic characteristic easily. Okay, how you should make a permanent magnet? So if you want to make a magnet, a piece of steel can be magnetized by stroking it with a magnet. If you want to make a magnet, then you should take a piece of steel and you can stroke them with the piece of a bar magnet. What will happen? All the atoms or molecules are aligned there in the steel, and the steel will become a magnet. But a better way of making a permanent magnet is to place steel inside a coil of wire. You can see here in this figure. You can see here, this is so-called the coil, okay? This is a wire. This is a magnetic wire. You can see here, and it is connected with a battery, and this is a switch. Once the circuit is closed there, and you place a piece of steel inside that coil, what will happen? A current will passing from the coil, and as a result, the steel will become magnetized. Okay, when the current is passing from the coil, what will happen? Strong magnetic poles are induced there in the steel, and as a result of that, the steel will become permanently magnet for a very long time. Okay, so this is the method how you should make a permanent magnet inside your house. You will take a wire, you should take a piece of steel, a battery, okay, and you should connect all of them, and you should place the steel inside the coil, and passing the electric current, what will happen there? That the current will be induced there, and as a result, after passing the current for some time, the steel will become magnetized and it will be having like a magnet. Okay, summary of today's lecture is a changing magnetic field around a coil of wire induces.
सर आप उर्दू में समझा दें समरी.
Yes, at the end I will explain inshallah in Urdu. Changing magnetic field around the coil of a wire induces an electric current. The second thing is when a material is pulled away from the magnet, it loses its induced magnetism called temporary magnet. And when the material is pulled away from the magnet, it's retained its induction magnetism called permanent magnet.